started with sinusoidal regression. Yes, again, we're going to use regression. Okay, so regression is a process, excuse me guys, where a curve or line of best fit is made. So technically, a lot of times they'll say estimate, right? Estimate the solution, right? And really when they say estimate, they're talking, please make a line of best fit. So our line of best fit in our regressions are always technically an estimate. And it's a very good estimate. Sometimes it's a perfect estimate. If it's 100, our R squared value is 1. And so we are going to now do sinusoidal regressions. So one last regression and then no more, I swear. It's our last lesson. So how do you calculate your regression equation? Well, turn your diagnostics on. Did you remember how to do that? You're going to have to remember all this stuff. Second 0. We want to go to our catalog. It's D, so you might want to push the alpha D so you can get there quicker. And turn our diagnostics on. And then push enter and it should say done. So we always have to turn our diagnostics on. Again, everything else is the same. So this is a review. We have L1, L2. We want to use the vars button, right? So we can put it into Y1. And we want, what's another way to get into Y1? We'll stick with what we know. So our R value, we really want to look at the R squared value, right? The R squared value, the closer it is to 1, the closer, that's the percent of data that's on our line. So if you have 0.999, basically that's 99% of your data falls on the line. If you have 1, it's perfect. If you get an R squared of 0.5, that's horrible. Okay, it's not a good regression. So let's go ahead and enter this into L1, L2. Hopefully you're going to be really good with all of this. It seemed like a lot that very first unit we covered it. It's very repetitive. We've been doing this for almost 2 months straight. At least it feels that way. I don't know about you. Okay, so time, height is a function of time here. 1.5, 2, where's it going to 3? 2.5, and 3. Uh-oh. On your diploma, please, please promise me you'll go back and check your data entry. Because that is the worst. When you type something wrong, and you did all the work right, and it's a numerical response question, and you get it wrong just because of that. Thank you. I solemnly swear. Okay. So the steps are going to be the same. Does everyone have it typed in? Or do I need to wait a second? Got it? A lot of you are quicker than me. Some of you may be slower. That's okay. Okay, so where do we go to get a regression equation? Stat, calc. Now if you push the up arrow, unfortunately there's no quick way about this because it's letter C.
Alpha C.
Maybe, but is that quick? I mean, it's up arrow twice or alpha C. Alpha C. So really, it's one or the other.
Alpha C.
Alpha C, okay. Don't push enter yet, because what do we want to do always? Bars. Why bars? Enter, enter. It's all the same, right?
No, but it always tells you what kind of regression it is.
Yeah, yeah. Or they'll tell you figure out which regression is best, and that's where the R squared value comes in. Okay? And when you go zoom 9, you usually can kind of see which type of graph it should be. So unfortunately, it only gives you for exponential, linear, and what else? Cubic, quadratic, it'll give you an R squared value. Sinusoidal, it won't. What you'll have to do is go zoom 9 and just look at the graph. Does it actually model a sinusoidal regression? And in this one, okay, my plots are off. How do we turn them back on? Yeah, push enter. Now let's try this again, zoom 9. See, whenever your data goes up and then back down again, it's sinusoidal. So you can usually figure out if it's sinusoidal if it increases and then decreases, or decreases then increases. Okay, so you should have had this equation, yes? So let's write that down. If we want to get fancy, does anyone recognize anything special about this equation? There's pi in there, so our b value could just write pi. So 1.5 sine of pi x, and then our c value is negative 1.57. Does anyone know what that is? No? It's okay, it's half of pi.
So in the diploma, it asks you what the equation was, and it said 1.5 sine 3.14x or pi x. Would you pick pi x, right?
They wouldn't do that to you. No, it would just be one or the other. Yeah, they wouldn't do that to you. Why is yours different? So go back to your list. Is everyone else's the same? It's in the right mode. What mode are you in? Yeah. Your list is, I'm sure there's something has to be off. Something has to be off.
0, 1.5, 1, 1.5, 2, 2.5, 3, no, 65, 66.5, 68, 66.5, 65, 66.5, 68.
Okay, let me just try one more time for you. It's the same.
Look at the graph. Why is my graph?
Zoom 9. Oh, it's because your windows are probably reset. Go Zoom 9.
I did.
No, you didn't. Yes. They'll tell you. So often it's like 4 decimals, like tenths. Yeah. Okay, next question. The table below. Use the time in minutes versus the height of a Ferris wheel with diameter 76. Ferris wheels make amazing diploma questions. They really do, and that's something you might see. Okay. They usually like to make them the same difficulty for both semesters. Usually over the years, as the years go, they get harder and harder. But who knows, right? Like, I mean, when you have your passing rate is 53%, that's something that they usually like to have a little bit higher than that.
Yeah.
Right? The average was 53. They like their average to be around 65. Yeah, they had 33% of students failed. It's 1 in 3.
No biggie.
Yeah, no biggie. And the average was 53. So they like their average to be a little higher than that. So, but they won't make changes at this point. Like the exam was set in stone before September for these 2 exams.
Oh, really?
So they won't make changes.
So it's going to be hard.
Chances are it's the same difficulty, yeah.
So pretty much you got to go home at home.
So we are going to diploma prep it up.
No, they probably changed it after they got the results from last time.
They don't. It's set in stone, lock and key, just kind of like the US, right? Where it's like super secure. And they make them way in advance. Because technically they piloted these questions. They have piloted them.
Do you know like what's going to be on it kind of stuff? Like do you know to consider being a system for
Yeah, I can tell you what it was last diploma, and I'll give you some ideas when we go through the prep. Okay, so stat calc, sinusoidal regression, vars, y-vars, enter, enter. This is like very repetitive by now, right? Hopefully. It's just kind of a pain when there's a lot to enter. All right, so there's our equation. And there's some more questions with this one, right? Now they tell us to put our windows to something, right? So they want our windows to be here. So let's go to our windows and change our windows. 0, 18, 1, and then 0, 90, and 10. Now question for you. What in my equation can help me figure out my y's windows? Which values? Which one? Okay, so we want our max and min. So on our regression equation here, which values help you figure out those? Because there's no max and min in the equation. A and D. So D plus A can give you an idea. So they're doing 46 plus 38 is about 90. Then 46 minus 38, well, let's go to 0. Right? You want to go a little above and a little below that. What value can help you get your X? Your B. How do we get the period? 2 pi divided by your B value. So if I did that, I can know 1 full revolution is 9. So why did they choose 18? How many revolutions will we have? 2 revolutions. Okay? So you can use your equation to help you figure out your windows. That's how these windows came from. So why? You look at D plus A. For the X, you're going to go 2B over your B value. And that gives you how long it takes for 1 revolution. And you might want to do 2 revolutions. Okay, so let's graph this. And your graph should look like this. Well, we expect to see 2 full revolutions here. And we do. Beautiful. Andrew, you with me? Okay, determine the period of the graph. Well, we kind of already did this. How do we get period? 2 pi over b, which gave us, what was our b value? 0.69. It gave us 9. 9 what? What's our x value? 9 what? Let's look. 9 meters or 9 minutes?
Meters.
Think about period. How long it takes to rotate? Minutes. X. So if you look inside here, everything inside these brackets relates to x. Everything on the outside relates to y. Okay, Sawyer, do you need to leave? Exactly. Get your pencil out and let's go. So your b value, everything inside these brackets the b and c value relates to x, and d relates to your y, max and min. Okay, so 9, and that would have been, we just said minutes. What is the relationship between amplitude and diameter of the wheel? We talked about this before. I don't remember. What's the relationship between amplitude and diameter? So if you think about it this way, we're graphing height versus time, right? And this is my amplitude. How is that related to the diameter? It's half, right? Or we could say diameter is 2 times the amplitude. 2 radius or 2 amplitude? Your amplitude is your radius of your Ferris wheel. This you need to know. Okay, if you know this, that would make it a lot easier. I mean, you could figure out your max value, your min value, and then subtract them. But it's a lot easier if you just know that whenever we're dealing with a circle rotating, it's 2 times our amplitude. Or, what was my A value in this question? 38. So 2 times 38 gives you 76 feet. Is it in feet? Meters. Thank you.
So we want the max and then also subtract it.
Yeah. Yeah. Right? Because if you have a circle, if I figure out my max height and my min height, the difference would be my diameter. Okay. How high above the ground do people board the Ferris wheel? So what are they actually looking for? Max or your min? You board at the bottom. It's pretty hard to board. You have to climb a lot of stairs. Sorry, a lot of stairs if you had to board at the top. So we're looking for our minimum value. What formula can we use to find min? D minus A. So our D, or midline, was, grab my 46 minus 38, which gives you what? 8. So 8 meters off the ground. many more do we have? Okay, well, let's see. Let's at least finish this question, guys. Let's finish this question.
Goes to K.
Okay. How far above the ground would a person be after 3 minutes? So how would you find this?
Graph.
Okay, graph. So second trace, 1. Is X time or is Y time? X is time.
Wait.
Height, you're graphing height versus time. So X is time. So 65 meters. At what point is a person 15 meters off the ground? So meters is Y or X? Y. How do we put in a new Y value? Y2. Okay, so they said what time? What points? We did second, trace, 1 value. And then, 3 enter. So here we want to go Y2 equals 15, and then what? Kai, what would we do next? After you type in Y2 equals 15. Okay, so Y2 equals 15, then what? Second trace, what? What are we looking for? You're looking for the, what's that called? Intersect. Okay, let's go in the first revolution. Okay, just in one revolution. So we have second trace 5. So we'll do both of these. I'm already here, so I'm going to do this guy first. So at 8.1 minutes, well, I guess we should get all of them, hey? Well, we actually could figure out the rest pretty easily if we know the period. Second trace 5. It's happening. It'll get there. So suspenseful. It's made it. Okay. 0.88 minutes. Now, it's really easy to get the other two because this is the first revolution. How long does it take to do another revolution? What was our period? How many minutes? 9 minutes. So to get the next one, we could just add 9. Just 9 minutes, it'll go around again. So 9.88 minutes, it'll reach that spot again. And then add 9 again. 8 plus 9 is 17.1 minutes. So we don't even have, once you get the first two, we know those are repeating every 9 minutes because that's our period. That's how long it takes to go once around again. 9 minutes, depends how, this is a pretty big one, right? And they're usually loading people on and off. But I guess, yeah, this one they're just going around. It is kind of a long ride. Yeah, often they are. It's not a ride you go on to like for the thrill. No. How long to the nearest tenth of a minute is a person in one revolution when he's at least 15 meters? Let's skip this question. I don't like this one. It's worded poorly, Jesse. That's why I don't like it. Okay, write the equation of the median line. What would be the equation of the median line? Y equals what? You could do max plus min divided by 2, or is it already in the equation? It's our d value. Y equals d. What's my d value here? Was 46. So y equals 46 is my midline. So that's when you're at halfway. Yep. Always. Okay, this is an important question. So this is how they like to give you diploma questions. As you see, okay, how did it change? So a new Ferris wheel is constructed that is 1 meter higher when boarding than the original wheel. Describe the effect of the new height of the wheel would have on each of the following. So all it is it's a new one that's 1 meter higher. Okay? So what is this effect? So all it is, it's just we want to board 1 meter higher. Okay? So the amplitude of the graph, would that change? Did we change the radius of the actual Ferris wheel or diameter? No. So that would not change. Would the period change? So how long it takes to go around? No, not change. Yeah, so if you just move it up, but it's still the same diameter, it would still take the same, it's not longer, it's just we just moved it up. Okay, how about the median of the line, the middle? Yes, that would change. How about the height of the graph? Yes, that would change. So the median is the D value. That's the one that would change, the D value. So the new function of the graph, everything would be the same except for D. So our new equation would be y equals 38 sine, what is the B value? 0.698. X, the C would stay the same. What would be my new D value? Plus 47. Yeah, so this would change. And last, we'll leave it at here. What parameters affect the maximum height? Which two values in the equation? A and what else? D. D plus A, right? Your midline plus your amplitude will give you your maximum height. All right, so there is one more question there. I think we'll leave it. It's a lot to enter into your calculator, so let's leave it there. So I have some instructions. There's a couple I want to omit on your homework. So open up your homework. Oops. Yeah? No, it's just extra practice. Okay, if you can open up your lesson, your homework. Okay, so on your homework, 1, 2, you can omit number 3. Omit number 3. And omit the written response, which is number what? It's a really bad question. So 3 and 6. Omit number 3 and 6. Okay, if you missed that because you were talking, too bad, you have to do them. Okay? All right, so it should be short and sweet. So why don't you get started on that? Also, did anyone not get, let's stop this video.